In this video, we want to look at the formulas for the resolution of vector. And we want to know how to apply those formulas. Now, let's say we have the coordinate system. In the coordinate system, we have the x-axis, positive x-axis, y-axis, positive y-axis, x-axis, negative x-axis, and negative y-axis. Of course, this is the east, the north, the west, and the south. The angle of inclination for the vector must be noted. If the angle of inclination of the vector, let's have this vector, is going towards or inclined as the positive x-axis, notice that the angle of inclination is at the positive x-axis. It is different when we have the angle of inclination at the positive y-axis. So we need to take note of the angle of inclination before we start looking at the formula to use. Now, let's start up with the first one. Now, before we start up with the first one, we need to also know how to resolve the angles of inclination and the reference angle. For instance, you can have vectors that will be inclined here at the same time. So we have a vector over here, we have a vector over here. Now, these vectors has an angle theta, has an angle theta, has an angle theta. Now, the angle of reference and the angle of inclination at the first quadrant is the same thing. So theta over here is equals to the reference angle. But when you go to the next quadrant, the second quadrant, then you know that the theta is equals to the reference angle, but the reference angle is equals to 180 minus theta, which is theta 2 actually at the second quadrant. Okay, now you need to subtract 180 from any of the angles you are given here to get the reference angle. But when you come to the third quadrant, the theta, which is equals to the reference angle here is simply 180 plus theta. So 180 plus theta, you will get the reference angle at this place. Although we have a video on that, you can check out that video for the clearer explanation. Now, you know that over here we have the positive y and then the positive x. Over here we have the positive y and then the negative x. Over here we have the negative x and then we have the negative y. Over here we have the positive x and we have the negative y. You should know that. Now, let's say we have a vector and the vector is traveling towards the x-axis, is traveling towards the x-axis. A particular force or a vector, force is a vector anyhow. So the force is traveling towards the x-axis, inclined at an angle theta. So you need to know that this force has two components. It has the x component and the y component. Let me use the red pen for that. So we have the x component and then we have the y component. Now, having said that, this becomes my fx. All right. Now, if I should join these angles, if I should join the direction of this vector together, I'll be having this to be my fy. Now, having said that, you need to bring back the knowledge you have about trigonometry. Now, in trigonometry, we use the knowledge of SOHCAHTOA to find the sine, to find the x-axis, y-axis, or the direction. So we have the car, and then we have the tour. So let's start off with the sine. So before I do that, I need you to understand that this is the opposite. Okay? Now, this is the adjacent. Now, this is also known as the vertical component. This is also known as the vertical component. This is also known as the horizontal component. Now, you should know it can be called the fx component, f of x component, can be called also the horizontal component. All right. Now, this can be called the f of y component or the vertical component. But understand that in trigonometry, this is opposite, this is adjacent, and this is the hypotenuse. Now, for the sine theta is equals to opposite over the hypotenuse. Now, sine theta, please, where does the opposite fall? That is the fy. And then where does the hypotenuse fall? That is the f. So that if I put a 1 here and cross multiply, fy is equals to fy, yeah, is equals to f sine theta. Now, this is the formula we use if the angle of inclination is towards the x-axis. Now, let's solve for the next one. For the cosine, so cos theta is equals to adjacent over the hypotenuse. Adjacent over the hypotenuse. So that we can have that if I put a 1 here and cross multiply, okay, now just cross multiply now, we have adjacent for hypotenuse. Let's look for the adjacent. Adjacent is f of x. F of x. Now, where is the hypotenuse? Hypotenuse is the f. If you put a 1 here and cross multiply, f of x is equals to f cos theta. Now, this formula is what we use to find the f of x component, the f of x component or the horizontal component. Now, this formula here is what we use to find the f of y component or the vertical component. Now, what of the direction? For the tan, that's what we use to find the direction. Tan theta is equals to the opposite over the adjacent. Opposite over adjacent. Let me clean up a little here so that tan theta is equals to, where is the opposite? Is f of y. Where is the adjacent? Adjacent is f of x. If you take the tan inverse on both sides, take tan inverse on both sides so that theta will be equals to tan inverse. Take tan inverse on both sides. Theta will be equal to tan inverse of f of y over the f of x. All right, so these are the formulas to use. Let me bring it up for you. For the f of x, or for the horizontal component, it is f cos theta. For the f of y, or the vertical component, it is f sine theta. Now, for the direction theta is equals to the tan inverse of f of y over the f of x. Now, this is only used when the angle of inclination is towards the x-axis. What if the angle of inclination is towards the y-axis? What do we do? Now, let's clean up the board. Of course, we'll still use SOHCAHTOA anyhow. All right, now let's replace the SOHCAHTOA again because it's going to be used again. Now, we have, let's put it back. All right, so we have, if our angle of inclination is towards the y-axis, now this is the x-axis. Now, if the angle of inclination is, the force travels in this direction, and then the angle of inclination is towards the y-axis, theta is found here. Now, you should understand that you have to make out a triangle, trigonometry. Now, if you make out a triangle from here by covering up to this side, all right, by covering up this side, you'll understand that you can form a rectangle from here so that the angle here is equals to the angle here, which makes it an alternate angle. The angle here is equals to the angle at that side. So we have this triangle. So our theta is here. Now, if our theta is here, opposite will now be here. adjacent will now be here. Of course, this is our hypotenuse. Remember, this remains our f of x. This remains our f of y. And this is the horizontal component. This is the vertical component. Okay? Let me check up the pen. All right? So, having said that, so what we're going to do now is that we need to find the sine. Sine theta is equals to the opposite over the hypotenuse. All right, opposite over hypotenuse. All right, which one is the opposite here? Opposite here is f of x. So I have f of x. Hypotenuse is the f. So I have f over here. Now, f of x, if I should multiply by f and multiply by f, or you put a 1 here cross multiply, then this will cancel this. F of x is equals to f sine theta. Now, for the angle inclined towards the y-axis, the f of x component is equals to f sine theta. Now, let's go to that of the cos theta. Cos theta is simply adjacent over the hypotenuse. Now, please, what is the adjacent? Adjacent here is f of y. So I have this f of y, hypotenuse is the f. If I should multiply by f and multiply by f, f of y is equals to f cos theta. That is for the f of y. Now, if you look at this, f of x is f cos theta. But over here, f of x is f sine theta. You need to be very careful with that. F of x is just the opposite of the one over here. Let me take it again. F of x, if the angle is inclined here, is f cos theta. F of y is f sine theta. But over here, f of x is f sine theta. Then f of y is f cos theta, if the angle is inclined towards the y-axis. So let's look at the tan inverse. Tan is equals to opposite over the adjacent. Please, the tan theta is tan theta. Tan theta is now equals to, where is the opposite now? Oh yeah, let's come back here. Opposite is f of x, and then adjacent is f of y. So we take the tan inverse on both sides. If you take the tan inverse on both sides, tan theta will become tan inverse of f of x over the f of y. So it's just like everything we do here, we just like the opposite of it. Okay? So you be careful whenever you are solving for the vertical component. If the angle of inclination is towards here, the horizontal component is f of x, f cos theta. Then over here, the vertical component is f of y, f sine theta. Then of course, the direction, tan inverse of f of y over f of x. Now, for over here, if the angle is inclined towards the y-axis, understand that f of x, which is actually the vertical component, what is it now? F of x now, vertical component is now f sine theta, instead of that of f cos theta. You understand that? Then f of y, which is the f of x, which is the horizontal component now, horizontal, is equals to f sine theta. That is for the horizontal over here, if the angle is inclined towards this side. All right? Now, for the f of y, which is the vertical now, vertical, we're supposed to, in this place, is sine, but here is cos. You get the point now? So that's what we mean by that. So this one is also known as, let me put it here, this is also known as the horizontal now. Horizontal. This is also known as the vertical. In fact, let me put it for you. So this f of x is called for here, if the angle is inclined here, f of x is the horizontal, then f of y is the vertical. Of course, you know the direction. Then over here, f of x still the horizontal, f of y still the vertical. So you don't get it mixed together. Now, if you have a question, you drop it on the comment section. Our next video will be on resolution of vector. Thank you very much for watching. Please have a great day.